Welcome to the future.
Welcome to the Muxall Open Internet of Things video blog. I am your host, Michael Crane. Okay, so I was getting ready to test the high voltage board of our new barbecue controller, and I realized that my Variac, see if I can get it in the picture here, that my Variac doesn't work anymore. And if you've never seen one of these things, it's a, well, we'll just read the top of it. It is a variable voltage regulator model SC5T. Input 117 volts, output 0 to 130. And basically what it is, I've never actually opened one up, but just looking at the outside of it, it looks like it's just a big old toroid transformer. Variable one, of course. And I'm guessing this knob kind of moves a wiper up and down. Maybe some exposed coils inside there. But this thing, the light switch used to power up, and then I was kind of messing with it, and I noticed, the power switch used to light up, and then when I was messing with it, I noticed it kind of got a little wanky on me, and I did check the fuse. The fuse is, if I can get it out, the fuse is good, as you can see. And I did test it with my ohm meter. So I figured we would take this thing apart and see what's inside of it, okay? Okay, so the first thing I'm going to do is let's pull this front cover off. And I am guessing that power switch is probably bad. Just by the way it's wobbling around. In fact, I just heard something drop, which I'm guessing is probably a broken piece of plastic, or oh, I just heard something else drop. I think it's raining plastic parts inside there. Oh yeah. Yeah, and yes, it is unplugged, by the way. Let's see if I can get you guys a better look at this. All right. Well, here's the, if you can see in there. There's that better. Well, there's a broken switch. As you can see, it is disintegrated pretty much. There's the fuse. There's the VU meter, or the voltmeter. And here's the mains receptacle. Okay. And I'm guessing this is common. And it probably went into that switch because it has a light in it and it needs the common. Normally you just switch the line side, not the neutral side, but since it has a light in it, I'm guessing they had that in there for the light. Well, there you have it. There's the rest of it. Yeah, I think that switch is dead. But it would be a pretty boring video just to replace that switch, so let's take it apart and see what's inside this thing, okay? That knob is a little bit the set screw on that knob is very loose, but it is not. Whoa. I guess I pushed it down. There we go. Well, we just got to get the knob off now. Oh, did I lose the set screw? I sure did. There we go. Oh, no, I didn't lose the set screw. It's still in there. I just couldn't see it. All right. This thing looks like it's just going to pop off. There. And, okay, so according to Tim Reese's website, he says Variacs can best be described as a tapped inductor, where tap is a long conductive slider that moves along the length of the inductor, which is what we see right there. And I believe it's carbon. I read somewhere that's carbon. I tried looking for the schematic for this thing online, but it's either so simple no one ever published it, or it's so old that no one cares. But I see they still sell these, or something that looks like them, on Amazon. So I don't know. I guess they're just too simple. Anyway, one of the things that his website pointed out that I thought was kind of interesting is that unlike a toroid transformer, this is a toroid, but it's not isolated. And I'll put a picture in the video showing what Tim drew out on his web page, which I thought was pretty interesting read. It's not very long, and it's straight to the point. It's very good. It says on its page, the inductor is shaped like a donut, or toroid, with wire wrapped radially through the center hole and around the toroid. So, just like a regular toroid transformer. It says, unlike a transformer with isolated input and output windings, Variacs have a single winding that serves as both the input and output source. And it says the slider arm is equipped with a carbon contact that rotates on an axle located at the center of the toroid, which is exactly what we have here. All right. And he has some pictures. I'll link them in the video as well, and a link to his website as well. Let's see. It says the enamel insulation of the winding wire is removed where the carbon contact touches the winding, so that answers what we were looking at earlier. Even though it feels so smooth, you can't tell. And it says, so the contact forms a circuit through part of the winding, just like carbon brush of an electric motor forms a circuit. Okay. And basically, what it is, it's just a big voltage divider, right? And so like in DC, you have a voltage divider for, you have two resistors, and then you tap off the middle, and that's basically what this does, except this isn't a resistive load. It's an inductive load, since it's using AC. And so it's got common on one side, and I'm sure it's got some kind of resistance going through it. Let's see here. Getting high-res mode here. Let's see. So if we get on the last winding and the first winding, 1.2 ohms, I guess, somewhere around there. And then if we go somewhere towards the middle, what? Okay, so now we're getting 1.5 ohms. I don't know. I think I'm getting on top of some of this ceramic. There we go, 0.75. Yeah, so we got a little bit of a resistance, but most of it's the inductive resistance. Okay, well, let's see what we can do to to fix this thing. Okay, let's see. We've got. I guess we need to try to get that switch out of there. I'll go ahead and clip that off. So this is the common. This is the power in. Alright. See if I can get that. The switch is just about ready to just fall out of there. It's so old and decrepit. Alright. So, digging around in my junk box, I have this guy right here. 16 amp, 125 volts. That should work. Doesn't have a light. I don't know if it'll fit in the hole though. No, it's a tad too wide for that hole. The other thing I have is this guy right here. Sorry, you can't see what I'm doing, can you? It's this guy right here. And let's see if we can get him through there. No, can't get him through there either. But what's nice about this one right here is it's got a really big, oh, it's the on switch. I guess if you, depending on where you put it, it's it could be on either direction. That's pretty funny. If it had a spot in the middle where it would actually turn off, it would make sense, but that's hilarious. Huh, okay, well, keep looking. Well, it looks like either way, I'm going to either have to use the on switch, which is just completely bizarre. I kind of liked it because it would cover up that hole right there. Maybe if I trimmed it down a little bit, I could use the on and off there. Or this guy right here, I mean, it is close to getting through there. I could probably, I'd have to measure it, but yeah, it'd probably be a lot easier to get this guy installed in there. You know, just take a file real quick and file it down than it would be to try to get this guy to clip off in there. I'll have to take a look. Okay, well, I did a little bit of grinding and there you go. Yeah, just like I bought one, huh? You can see a little bit of a gap right there, but I think for the once in every 10 years that I use this thing, it's probably been once every 10 years. Yeah, I don't think anyone's gonna mind. That looks very good. So, I guess next on the list is we need to get her wired up and give it a test. We'll have to test the test equipment. All right, let's repair this guy. So, first I need to strip some wire off. Kind of close quarters here. All right, these are going to be solder-on connectors. First I'll crimp the strain relief to the outside. This is not easy to do working around a camera. This is a lot easier to do if you're sitting right in front of it. Okay, so I want to crimp the strain relief down to the insulation, wire insulation. All right, and I'm gonna crimp this to the wire. All right, now I'm gonna apply some solder. Hopefully my iron's hot by now. There's a lot of thermal mass there to heat up. I'm applying a little bit of solder. If you add a little bit of solder, it helps heat up the wire and the connector faster. Kind of like, you know, when you defrost something from the freezer, if you stick it in a tub of water, it'll defrost faster. Kind of the same concept. Well, I do believe that's okay. I'll have to take a closer look at it though. Well, I certainly applied a lot of heat to it. I kind of melted the insulation a little bit. That's not desirable. Let's see if this one can make this one a little better. This wire is a little bit on the crusty side. So I think on this one here, I'm going to add just a touch of flux to it. First, I put this guy on. I'm going to add a touch of flux. See if it makes that solder flow a little better. I mean, the solder I'm using as a rosin core, it's got flux in it, but it didn't flow real nicely in that last one. I mean, I think we have a good solder joint. I'm not too worried about that. It's just it looks a bit. How you doing? All right, got the strain relief. Clamp this over the wire. All right, now let's see if this one solders up a little better. Hopefully everyone can see that okay. Oh yeah, that looks much better. Okay, good. Alright, so the last thing I want to solder is this common right here, or neutral, or whatever you want to call it. And I don't have a regular crimp-on connector for it, so I'm just going to solder them together and put a piece of heat shrink around it. You got a little bit of a, there we go. Yeah, you can see this wire is really crusty. It's almost, I mean, this thing is old. I've had it probably 15 or 20 years, I guess. Okay, I'll put a piece of heat shrink around this guy. I'm just twisting these wires to keep them in place so I can solder them. Man, I tell you, they are crusty. And crusty is probably not the right word. They are oxidized. There we go. I'm gonna apply a little bit more flux on this. Oops. There, that looks pretty good. Okay, I'm gonna let this cool off for a minute. While it's cooling, I guess I'll go ahead and pull the covers on these guys. Hopefully I don't burn myself. There we go. Install him. Yep, if I can get him on there. There we go. That's a nice tight fit, that's for sure. and install this guy. And he's barely gonna reach. Hopefully you can see what I'm doing. There we go. It's tight, but it should be okay. Hopefully these aren't too deep. I might have to bend them over so they clear the transformer. But let's go ahead and get our heat shrink on there. There we go. There we go. Now the proper way to apply heat to to heat shrink is with a heat gun. But I don't really want to get my heat gun out. I do have one, and this works pretty good in the hands of a trained professional. There we go. How's that look? That looks pretty good, huh? Checking to make sure none of the wires are poking through. Looks okay. Got one a little close right there. Yeah, see, I can see one's poking through. Unfortunately, I think I'm going to have to redo that one. I don't like the way that one of the wires pokes through, and it's just way too easy for it to short out on something inside here when we go to assemble it, and we don't want that to happen, so I'm going to have to redo it. So first off, I got to get this heat shrink back off. I guess I should have checked the pokiness of those wires before I buttoned it up. Yeah, there's just a couple. I'll just cut this guy off. All right. Yeah, I don't know if you can see it, but see these wires right here? They're kind of poking up. And it was going through the heat shrink, and I didn't like that too much. So we're going to redo it. And that's okay. We've got a little bit of wire left here to play with. Not a lot. All right, let's try this one more time. I'll try to be very careful not to make that mistake again. It's funny that it's like two different wires. The darker blue one, you can probably see, has less conductors in it than the lighter blue one. And I believe that was the one that was poking through the heat shrink. This time, I still feel a little bit of pokiness, so there we go. Really, it just has to hold it so I can solder it, right? Yeah, that feels better. All right, I'll add some flux. Make sure nothing pokes up. Oh, everything feels nice and smooth. All right, let's get this baby soldered up. See, I'm adding a little solder to the tip of the iron to help heat up the wire. I'm also keeping the soldering iron under the wire since heat rises. It also helps heat up the wire. There we go. We're getting some, using all kinds of solder. Yeah, that looks okay. I'm gonna let that cool for a minute. I'll be right back. Okay, it's cooled off now, and I still feel a little bit of that wire poking out. I'm gonna squish that back down. I'm gonna check the solder joint. I give that solder joint a B. That's not the greatest. I could probably fix it up, but it's definitely good enough. Okay, so I do not feel any more sharp wires poking out. There we go. That looks okay. Get out our heat gun. And you don't want to burn it. There we go. Oh, much better. Yep, that looks and feels much better. Excellent. All right, and now it's just time to put it together. Okay, before I put it together, I'm going to give it a quick dusting. Probably last dusting I'll ever get. That is, looks like we got a little bit of a bad spot there. Generally, it looks pretty clean. Maybe I might take some alcohol and clean that up a little bit since we've got it apart. If you don't have any of these things are pretty nice. They're little alcohol prep pads for, well, they're medical, and I guess they're sterilized. So if you need to use them in a for a medical reason, you can do that too. But they're great for cleaning flux off of boards, I've found, and they're kind of handy. So I'm just going to wipe this down a little bit. It's actually not that bad. That's it. That's all the cleaning I'm giving it. All right. Blow this, dry it off a little bit. All right, yeah, let's put this baby together. Boy, that looks a little bit dangerous, doesn't it? I'm sitting there putting sleeves on my connectors, and they've just got big exposed pads there, or terminals. They've got big exposed terminals. All right. By the way, I don't know if you guys if you've never held one of these things. This thing probably weighs 15 pounds. I don't know what that is in kilos, but it's it's kind of heavy. I'm trying to get all the holes lined up there. All right. Give you guys a little better angle. I'm not going to tighten these up until I've got all the screws in it. That is a very good habit to get into. Oh, this thing is a lot easier to take apart. like I said, it's kind of hard to work around the camera. I don't want to knock my camera on the floor. And I want to be able to show everyone what I'm doing, otherwise you'll just be staring at blank air. Or you'll be staring at dead space. Alright, I think we got one more. Alright, I'm gonna go ahead and tighten him up because we've got all the screws in now. Okay, so the new speed connectors we we installed are a little bit too tall, so I'm gonna just bend them over a little bit, like that and like that. Yeah, let's see if that. Ah, yeah, that's better. Okay. Now, let's see if I can get this bottom one in without having to flip it upside down. These things are a little bit tricky to... Nope. There we go. This is where a third hand would be handy. There we go. I think I got it. All right. All right. Don't want to tighten it too much and bend the metal case. Well, it looks like a pot one. It even fixed our label problem. Yeah, because the off was about half wiped off there. Let's see. Last thing we need to install is our knob. I don't know why I'm checking it. It's slotted. Well, there we go. A little dusting. Excellent. All right. All right. Got my meter out. It's on AC voltage. That's always good. It's never good to turn it on ohms. Now plug this guy in. All right. And let's turn them all the way down. All right, well, let's turn them on. Oh, I saw the lights dim. Dim for a second. That's good. Woohoo! It looks like it's gonna work for us. Yeah? I don't know how accurate that little knob is. Let's see, that's 115 according to the knob. But there's no telling what the mains power is coming in to the lab. It's probably around 130, I bet. So let's see, this thing is set at, well, as far as you can tell with the knob, right? It's about 115. We're showing about 131 on the fluke here. Let me turn this off. Well, that's what it is coming into the wall. It's 123. So that's not too bad. You know, 115 to 120 is about normal. For our area. Actually, 120 is probably normal. So, I don't know what to do about the adjustment on this. I don't think there is any, really. That thing's slotted, but we can take a look at it real quick. One thing I didn't look at was this voltmeter. up here when we're adjusting it. Maybe I don't need to worry about the knob. Let me just plug in my probe. This is probably not good for this power receptacle. Let me plug in my my voltmeter probes in it, but okay, I'll just leave it at 115. So so let's turn it to 110. Okay, there's 110 on the knob. Yeah, the voltmeter, get everything in the same shot. Yeah, so the knob says 110. The voltmeter says 10, 20, says 120, which is, yeah, that's pretty close. Yeah, the voltmeter says 127. I mean, the fluke says 127. Yeah, that voltmeter, that's pretty close. There's not a load on it. I don't know if that actually would make a difference or not. Okay, I've got my, I don't know if you can read it, it's my hot glue gun. It's about 40 watts, according to the label. Nice resistive load. Let's plug it in and see if that makes any difference on how this thing regulates. There we go. And not an iota. Well, maybe a little bit, I guess. maybe 1 volt, or not even, maybe a half a volt. Yeah, so the knob says 110. This voltmeter says almost 120, right on the money. And this guy says 126. So it's 6-7 volts off. But I guess it's pretty good for what it is. You just have to remember, if you're going to test something, you probably want to make sure, check it with your voltmeter before you plug in your device under test, because you don't want to dump too much voltage in it. So I'll probably mark on mine. So I'll probably mark on mine where exactly 120 is. I'll mark it on the knob somewhere up here, and then get it dialed in using the fluke, and hopefully it's repeatable. I'm sure it'll change a little bit with power coming into the wall socket, but it should be okay. So 123 is what the wall socket said, and this is about 107 on the knob. And you can't even hardly tell with it didn't even budge on the voltmeter. This is just a rough estimate. I would just call that a rough estimate. Let's see. Let's turn it to 50. Okay, so there's 50 on the voltmeter. Well, 52. That's not too bad. Let's see, what does it say on the knob? Oh, it's actually better on the knob. It's in between 50 and 55, so I don't know, maybe it's dirty? Let's get it right on 110. Alright, so there's exactly 110. Yeah, see, we're not even up to 100 on the knob, so it gets a little crusty the higher you go up. But, I mean, it's pretty close, only, 2 volts off, with the fluke. So this would be like a rough adjustment, and then you need your fluke for a fine adjustment. Anyway, well, that's enough playing around with it. I call it good to go.
Don't forget, you can support the Muxall Open IoT channel by donation using a credit card and PayPal, or by purchasing products at the Muxall store. Details and links are in the description under this video. Well, that's it for this video. If you liked the video, give it a big thumbs up, that helps, and hit the subscribe button, that really helps. If you have any questions or comments, post them in the comments under this video. Thanks for watching, and I'll see you next time.